This is StarTalk Sports Edition, and this time we're doing a Cosmic Queries grab bag. Got with me Chuck O'Reilly. Chuck Nice.
God, you just married us.
I'm sorry.
Married us, and somehow I had to take Gary's name. What does that say?
Chuck Nice.
What is
Gary
going on
O'Reilly.
here?
I think of you as my one common conjoined co-host. I'm sorry.
Okay.
So, Chuck Nice, good to have you there, man.
Yes, Dr. Frankenstein, good to be here.
All right. Gary O'Reilly, former footballer from the UK and broadcaster.
Yes,
And we got a little piece of him for us. Very good to have you. This is a grab bag. And anytime we have a grab bag, this is like the bat signal going up into the clouds. We got to reach for our Geek-in Chief, the one, the only. And, hold your applause till the end. Charles Liu, Charles.
Hey.
Okay.
Hey Neil, hey Chuck, hi Gary. So good to see you guys.
A friend and colleague, astrophysicist Charles Liu, who's a professor of astronomy and physics at the City University of New York in Staten Island. Yes. And always good to have you here. You're a fan favorite. And so you're going to help us in this grab bag. I mean, I might be able to do some, but when it comes to really geeky answers to cool questions, I am unworthy, and I will just sit back.
Neil, you don't have to say that. But I'm happy to be here. It's always fun. So, and the questions are always the best.
They're always cool. They're always cool. So, Gary, Chuck, you got questions lined up?
Yes. Right. Let's start with one of our very favorites. And I can't do the voice anywhere near the ability that Chuck has, but it's Alejandro Reynoso.
No. Give it to Chuck. Why are you reading that? Chuck? Chuck.
Oh, I didn't know we were starting here, so
somewhere.
I gotta go pull up. I gotta pull up Alejandro.
Pull up the message. So again, all of our cosmic queries today are exclusively asked by Patreon members with our new entry-level category of $5 a month. So you can't argue with that.
All right, here we go. Let's start it off with our friend Alejandro Reynoso. And Alejandro comes to us
listen without laughing. Sorry, start again. I'm sorry.
Here we go. Alejandro Reynoso, who comes to us from Monterrey, Mexico. And he says, hello, or should I say, hola. My question is, how do you think we can use artificial intelligence in exploring the universe?
So there it is. So Charles Liu, what do you have to say about AI and our field?
Alejandro, let me tell you, you are right on the mark. And in fact, we are already trying to do precisely this. As many of you know, I am part of the Cosmos collaboration working with the James Webb Space Telescope. Neil, you're familiar with that.
Yes,
back when we were working on it with just the Hubble Space Telescope data, right? But now we have the James Webb Space Telescope
Just
data.
to be clear, the Cosmos collaboration is a consortium of people and institutions that have targeted sections of the sky just to hammer it with as many kinds of telescopic observations and detectors as possible to learn basically everything knowable about sections of the sky that we target. So continue.
Precisely.
So now we've applied this to the James Webb. So what do you have going?
Exactly right. Well, the James Webb Space Telescope's first season's most significant observing project is to use the James Webb to aim at the cosmos field, which you described so aptly just a few seconds ago. And so we are spending 270 hours of James Webb time in just a small patch of sky about the size of your pinky fingernail. And as a result,
at arm's length.
Yeah.
At arm's length. That's
Yeah,
right.
when you're
not right up close, but like
when you're looking up at the sky.
Yeah. Pinky at arm's length.
Yeah.
Not finger in your eyeball. Right. Okay.
Yeah, that would be difficult. So there's literally terabytes and terabytes worth of data coming from all the different observatories around the world, and James Webb is just layering on that next layer of information about this patch of sky. And no human being can individually process all of that information in any meaningful way in a human lifetime. So what we need instead is the opportunity to use machine learning, deep learning, artificial intelligence, to help us make sense of all of this incredible amount of information. So, for example, we have information about possibly 2 million or so galaxies within this cosmos field, ranging all the way out to 13.5 billion light years away.
Just to be clear, this fingernail at arm's length blots out 2 million galaxies on the sky.
That is correct.
To the edge of the universe. Okay.
Right.
Oh, man. Okay. I'm sorry.
But Chuck had an
No, I'm just trying to.
There. Okay.
I just thought of something that's a whole nother question. I'm not going to screw us up and get us off track. Like
especially since you're not a Patreon member, so you're not allowed to ask questions. Okay.
You got $5 on you.
Wait, hold on. Let me get my. Do you take credit cards?
What's the expiry date?
Okay.
Oh, damn it! It's expired.
So each of these 2 million galaxies has thousands of pieces of information about it that have been gathered by all these telescopes that have been trained on it for the past 20 years, off and on. And now we've added James Webb on top. Can we make a pattern? Can we understand what actually matters? Can we ask ourselves, can we look at all 2 million of these galaxies and find something new? Actually, probably not. But using artificial intelligence, we can do that. We can say, here are the parameters of what we think are normal. Can you please find for us all the normal things and then all the abnormal things? And then tell us what is normal and what is abnormal, or what should we be looking at? Right. And what should we be looking at that allows us to sort of understand the change of the galaxies in the universe from 13 billion years ago to the present day? I mean, that's a heady question, which any individual human can sort of grab the most creative and interesting ways. But processing all of that information, AI is the answer. Wow. We're not there yet.
So Charles, why isn't this just more powerful computing rather than what people generally today think of as AI?
Great question.
Because we've always needed computers ever since computers have been brought to our field. We've needed it to reduce and analyze massive amounts of data, even when massive amounts of data in the day was only a kilobyte or a megabyte. And so now we're up to terabytes. So isn't it just more powerful computing?
Number crunching?
Great question.
As opposed to thinking.
Great question.
Yes, it's really thinking.
Number crunching has been going up. It actually is extremely important. And you're right. That's most of what computers are doing for us in astronomy today. But it's that next step. I think it started maybe 3 or 4 years ago that we really started shifting over toward machine learning and artificial intelligence. So both are still working hand in hand together. And in the current circumstance, the AI part is still in its infancy. A lot of times when people publish scientific results that they found using AI or machine learning, they're probably not right. But we publish them anyway because we say, hey, it might be right. Please let the rest of us colleagues go back and check to see if what this machine found is actually something in reality.
The all-important verification step.
That's right.
Right. And so compare all of that to neural nets.
Well, neural net is just another way that we can abstractly map the idea of intelligence and pattern recognition. Right. Current,
because we think that's how our brain works. That's why we say neural, right?
That's right.
Just the connectivity to find patterns and whatever it is that might manifest.
That's right. The neural net itself is a pretty complicated thing, but we can strip it down to very basic components and say, can you do a one-dimensional or two-dimensional or three-dimensional discussion about all this information, try to make connections that we otherwise wouldn't be able to see if we were just trying to use one CPU by itself, one brain or one processing unit. The neural nets in our brains are not just three-dimensional. They're 4, 5, 6, 10. Each neuron attaches in many unusual ways to many others. So there's a sort of an emergence of awareness that comes about from these networks of that kind of complexity. So
Yeah.
these are the things. I think you did a Cosmos episode on this, right, Neil? Once
Yeah, we did,
about
yeah.
how
Mhm.
intelligence and the concept of a very complicated neural net like a human brain can actually be more complicated than even an entire galaxy worth of stars and their
Right.
interactions and so forth.
Wow.
It's very, very powerful, but poorly understood.
All right.
Yeah.
Are we looking for the right things? I mean, using AI obviously should be an advantage, but are we looking for the right? Because there must be things out there we don't know exist, but we should be looking for, but we don't know to look for them. Is AI going to be able to assist in us in that kind of capture of data?
In other words, can it discover what it's not looking for?
Right.
Thank you.
It can discover what it's not
exactly-
looking for. That's a great question. It can discover what it's not looking for if we tell it to look for things that it's not looking for.
Right.
Mm.
So in a sense, your number crunching, right, data reduction, or let's say computational work, that will give you the answers to things that you are looking for.
Right.
Now you tell a machine and say, these are what we are looking for. Can you tell us any exceptions to what we found?
So
And it will be
anything,
able to
it would have
find
to be
those.
something anomalous, but wouldn't you have to program the parameters of what an anomaly is? in
No,
order
no.
for-
You only have to know what we're familiar with, and anything that
Well, anything else
doesn't
would be
fit
an
in that
anomaly.
box would be
Right.
an anomaly.
That
That's
is an
all.
anomaly. So okay,
right.
so that means well, that is kind of
That's
like
the easiest part of the
Yeah.
part of the job. If it doesn't fit, stick it
If
in
it
a
doesn't fit,
box.
then right, it goes, oh, that's odd. Okay,
Right.
now let's look at that.
The
Okay.
search for
In-
outliers. The
In fact,
search for
60
outliers.
years ago, one of our colleagues did that. He looked at all these beautiful galaxies in the night sky. And there's a beautiful spiral and a beautiful elliptical shaped galaxy.
And the
Who
sombrero.
ordered this one, which was tangled and mangled? And he made a catalog of just the tangled, mangled looking galaxies. And it was called the Atlas of Peculiar Galaxies. and it was the catch basin of nothing that fit anything else. And Charles, you remember, it became one of the most studied catalogs in the canon of cosmology.
Alton C. Arp, Chip
Yeah.
Arp's Atlas of Peculiar Galaxies, published in 1966. Yes,
Yeah.
tremendously interesting. And what it was it turned out that Chip Arp's ideas of why they looked peculiar were incorrect. But by putting them together into a catalog, people could look at them and start wondering and thinking about what actually was going on. And it helped us understand that galaxies collide, that they crash into each other, and they create amazing structures which we could not have imagined had they not collided. And that led to the entire field of computational astrophysics as applied to galaxies. And
And by the way,
cosmos.
and we needed the computers to make that happen. So that was in the 1970s, computing power rose to then say, well, I wonder what a galaxy would look like if it collided with another galaxy. Hey, that matches ARP's catalog number 32.3. And and then you look at it at a different angle. That's a different object in the catalog. And so
Hey,
all
let
of
me
a
ask
sudden
you,
we
when you
would
guys
explain
say
all the
collide,
galaxies just as witnesses to train wrecks.
You guys keep saying collide. When you say galaxies collide, is it that the galaxy's gravity affects another galaxy's gravity, or are you looking at actual objects hitting one another? Because aren't galaxies so spread out? What is it? What's an actual collision?
Chuck on the case.
What a beautiful question. Beautiful,
Ooh,
beautiful
good one,
question.
Chuck.
When galaxies collide, when galaxies collide,
That's a movie title right there. We need that one.
Yeah.
the stars are so far apart that they almost never hit each other directly. So it's like swarms of bees or hornets, nests swinging through one another and affecting one another from a distance.
Okay.
But a collision doesn't have to happen only when a physical object hits another physical object.
okay.
What you said, the gravitational effects of one object affecting the other, is indeed as much of a collision as we might think of, say, two vehicles hitting one another or something. And so instead, you get these twists and turns, you get bends, you get loops and whirls, and it is all gravitational. Yes, indeed. So it's
Sweet.
Yeah,
really
so
remarkable.
we count a gravitational counter as a collision because they affect each other. But I've quantified this bee analogy. So if there were 4 bumblebees flying randomly across the continental United States, the chances of them accidentally bumping into one another is the same as 2 stars colliding in 2 galaxies in an encounter. So yeah, basically
That's
2
right.
stars are not going to physically
Right.
collide, but they'll all feel each other's gravity, and that's enough to make a train wreck. So
Ooh,
And
I
a
see.
beautiful train wreck they can be. These kinds of
Yeah.
train wrecks cause the formation of new stars, new planets, sometimes in the billions at a time. They feed
Yeah.
supermassive black holes. They create quasars and active nuclei. They're one of the most important engines of the evolution of the universe itself.
Ooh,
Wow.
the evolution.
Look at
Ooh.
that.
We got to take a
Ooh.
quick break. When we come back, more Cosmic Queries grab bag. We'll be right back. We're back. StarTalk Sports Edition. Cosmic Queries grab bag with our Geek-in Chief, Charles Liu. All right. And of course, Chuck and Gary. Give me some more questions. We're on a roll here. What do you
Okay,
have?
this one I think is pretty topical. So this is from Samuel Fairchild. Greetings from San Antonio, Texas. What can we learn from the runaway supermassive black hole that was spotted by the Hubble telescope trailing a 200,000 light-year long tail of new star formations? Answers,
Ooh.
please.
Oh.
It is most likely a classic example of what happens when galaxies collide.
There you
When galaxies collide,
go.
Yes.
lots of things can happen.
In a galaxy
the
far,
things-
far away.
Yes.
They could be far
Yes.
away. We hope they're far away, but they could be close by. Remember, in a few billion years, the Andromeda galaxy will collide with the Milky Way. Then we'll have a close-up view of what happens when galaxies collide.
Okay.
So the story is this, right? You have a galaxy, and it's about 100,000 light years across. Here comes another galaxy that's also 100,000 light years across. They hit each other at just the right angle, and you can pull a trail of gas outward a couple 100,000 light years long.
Wow.
When that happens, you're basically creating a stream of new stars forming all along this trail. And so there's your 200,000 light years long trail of new stars forming. Meanwhile, part of that collision could have hit, and there are many different ways galaxies can collide, but perhaps in just the right angle and at just the right speed, the supermassive black hole in one of those galaxies got stripped out of the body of the galaxies that are colliding. So whereas the rest of the galaxy's material is sort of coalescing into a single blob, that supermassive black hole is out on a trajectory that looks like it's following that gas going outward. There's a lot of possibilities, and we've only just begun to figure out what's going on.
And by the way,
Using
the
s-
gas, unlike the stars, the gas doesn't really pass through itself. When the gas collides, it's like two hot marshmallows sticking. So a lot of interesting things can happen in the gas part of the colliding galaxies,
Yes.
separate
can-
from the stars.
Right. You can often think of the gas in a galaxy like the water in a swimming pool or something. They have a dissipative force. They are viscous. Even though they're very sparse by Earth standards, they wind up out in space, sort of along the millions of years type time scales and the millions of light years type size scales, acting very similarly to what you might expect.
So Charles, I did an episode of Nova Science Now once where it was exactly that reference. I was at
Yeah.
a swimming pool and I had a bucket, if I remember this correctly, I think I had a bucket of ping pong balls and so did someone else. And we tossed them towards each other and only a few of the ping pong balls would hit each other. But then we had buckets of water and we threw the buckets of water at each other and the water just, it was there, as you said, it's
Oh, that's
dissipative.
fantastic.
Yeah, it was a fun, and we did it in slow-mo and you can see it. It was pretty cool.
All right. Next question up is from Mo, M-O-E. Aloha, Neil and Chuck. What evidence can you provide to show that we aren't in a simulation?
Aren't.
Are not.
Oh, interesting.
Okay.
Proving the
This-
negative. Can you prove the
Here-
negative?
Here's the
Okay.
story, right?
I have an attempt at it, but go on. I want to hear what
Yes.
what my Geek-in
Rene
Chief has to say.
Descartes. Rene
Ooh.
Descartes,
Ooh.
hundreds of years ago, right? The guy who, after whom we've named the Cartesian coordinate plane, but also a great philosopher, a rationalist of his time.
Right.
I
Basically-
think, therefore, I am.
I am.
Yes.
That's
Yes,
him.
that's right. And he basically set out the idea that if there were a simulation that was good enough, we would not be able to tell. There's just no philosophical way to tell as long as the simulation is good enough. So the only evidence that we can give that we are in a simulation is if somehow we see a glitch. You may remember the movie Inception, when the people in the dreams were trying to figure out whether or not they were in a reality or not in a reality. And one particular person figured out that he was in a dream because the texture of the carpet was different from what he remembered in reality, right? So every single piece of evidence out in the universe has to be consistent with what we think is real, right? And if not, if there's a glitch, then we're in a simulation. We can also go to the Matrix and talk about that.
The film.
And how what they said,
the cat scene,
the reason they were able to know they were in a simulation was because something just didn't happen correctly. That's the only way, according to Descartes, that we can prove that we are in a simulation. But how can we prove we're not in one? You just have to keep looking for the glitches.
Oh, wow. Look at that.
Well, but so if we don't find any glitches, we're either not in a simulation or it's a perfect simulation. And therefore, what's the point of even distinguishing the two?
Correct. That's
well, then, okay. So with that line up with paranormal activities counting as a glitch.
Ooh.
So paranormal activities are not, following the laws of nature or physics or what have you. Would that count as a glitch? That would say that we are.
So what are we calling a glitch? What's the definition?
Yeah. Or a miracle. A miracle is something that happens outside of the laws of physics. That
miracles and paranormal activity at this point in our understanding of the universe are only things that we don't understand yet. There's nothing that's been shown to be conclusively a violation of the laws of physics, just something that we haven't explained the rest of physics yet.
Wait. Jesus walking on water violates a ton of laws of physics right there.
If that actually happened.
Oh, now,
shots fired.
In all defense, he had some really good sandals. Okay,
he did. Could it have been?
Sandals.
He had Jesus sandals now.
Jesus.
Right.
Okay.
So we all have to think about these questions as skeptically and as optimistically as we can at the same time, right?
Okay, I got to add another pop culture reference.
Sure.
My single favorite episode of the 2.5 seasons or whatever it was of Black Mirror was the episode titled "Hang the DJ," which has nothing to do with the entire story. It's the name of the song that you hear at the end. In that, it's a dating community. You date multiple people to see who one you like, and then at the end you get married to them. And we learn, should I give it away? I have to give it away, otherwise I can't talk about it. We learned that all the people in this story are being simulated. But you don't know this because you're with them and they're testing their dating. And that didn't work out. Let's date another. I got to stay 3 months with this person. It's all prescribed and it's all do it. And they hate each other or they love each other, whatever. And one of the women who likes skipping rocks, skipped rocks and said, every time I skip rock, it only skips 3 times. And she said,
she figured out the glitch.
Some should skip 1 and some should skip 4. She just tossed it up, and you don't even know to pay attention to that when that's happening. All right. These are characters that have their own sense of free will. And one of them noticed that every time she skipped rock, it was exactly and identically 3 times. And we later learned that all of these people are a simulation, so that when at the end you emerge and the 2 people, they escape they escape this place. And as they escape, you see the digitization of things happening. And the next scene are 2 people meeting up in a bar who were matched by that simulation. It was like, holy shit.
It's the ultimate swipe left. Swipe right.
Yes.
Yeah.
So the simulation tested everybody's compatibilities. And it was like, oh my God. But in it was that one observation. So ever since then, and a little bit before then, I've been checking for things that maybe should have different kind of variation than what should. That's interesting about the carpet, though, Charles.
Yeah. But do we then project our desire to find a glitch into our thinking and observations.
Yes. Without question, Gary, that's a great point.
Well, so it creates a bias. Ooh,
We
yeah.
humans are biased in one direction or another in general, right?
Yeah.
And just like it's very hard for all of us to be rational all the time, and maybe we shouldn't be, the circumstance is of our detecting whether we're in a simulation or not are almost secondary in importance to whether or not we are in whatever environment we are, real or simulated, and live the way we want to live and do the things we want to do.
So in my recent book, Starry Messenger, I reflect on what a simulated world would be. And I use that as evidence that we're not in a simulated world. You know what it is? A simulated world is created by computers, and computers are absolutely logical. And so no set of computers would ever create the world we live in. So it's the inanity defense. It's like Earth is inane in every way. Computers have higher integrity than that, even in a simulation. That's my evidence.
That's great evidence, except that you may be putting too much stock in our inanity. It may well be that inanity is an inherent part of logical systems. We just don't know yet. I know.
Okay,
I
Neil,
know.
would a computer be able to generate or recreate love?
I don't see why not.
Easily.
Sure.
I don't see why not.
Depends on what you
Easily.
think love is.
Well,
Depends
no,
on
I
what you
got
think
this.
love
I
is.
got that. This is where I'm past that. Okay. So watch. You get everybody who's in love with something or some other person, right?
Okay.
And then you do a brain scan. And I'm making this up, but it's plausible. You do a brain scan, and everyone has the same part of their brain lit up while they have these feelings of love.
Right.
Then you take someone who doesn't have those areas of the brain lit up and show them something that's completely neutral, right? Like a book, just a book cover or something. Then you light up that part of their brain and see if they fall in love with the book. And if they do, we know exactly what love is. It's the neurosynaptic of this section of the brain. There it is. And we can create it for you if you want it. If two people are long marriage and they're falling out of love, go back and re-stimulate. They're back in love if they're like newlyweds.
Yeah.
I mean,
clearly love is a neurochemical synaptic function of the brain.
Yes.
I mean, it just has to be on a biological level. Otherwise, you can attach ethereal qualities to it, yes. But I mean, people who, if you are brain dead, you can't be in love.
Right. In fact, you don't have to be fully brain dead. You can be partly brain dead in a section that would matter in that category.
Right.
But sometimes it makes no sense.
Wait. As a matter of fact, we have people who are incapable of love. Okay. We call them sociopaths.
Yes.
And
or they're incapable of empathy. Yes.
Capable of empathy, but you have to have empathy to have love. So
imagine a person
all right,
who does not imagine a person that is somehow perhaps what we might call defective and unable to experience empathy or love. This person carefully studies thousands of people who are happily in love, figures out all the behaviors that are observable from an outside person of how to be a person who expresses and shows love, and then just mimics all those behaviors beautifully. Running into a person or choosing a person to treat that person that way, to work with that person that way, to do the things with that person that all those other people in love are behaving. Is that person exhibiting love to another person?
It is
not
not.
part of the brain.
You can't tell.
Not from the outside. That's why we go inside your brain with the brain scan.
That's what a brain scan is for.
That's the whole point of the brain scan.
If you don't have that part of the brain lit up, but you behave as if that part of the brain were lit up, are you still behaving with love?
So I'm going to say from a utilitarian standpoint, no, you are not, because the only reason you would do that is because somehow you are being served. Otherwise, you would not be a sociopath. You would actually be exhibiting love itself.
Right,
Perhaps your definition of behaving in a way that's self-serving is to behave in a way that everybody else in the world looks to you as if you are in love. But then are you? You may not be from your brain's point of view.
Charles, that's why I introduced science here, where you go inside the brain.
But
That's the whole point of that.
I'm asking you a different kind of science.
Mhm.
From the observable perspective, assuming no hidden variables, okay, assuming that the interior of the brain is unknowable for
I'm
some
not going to.
reason.
I'm not have to assume something that's not true.
But quantum mechanics, for example, suggests that indeed there are things about particles at certain levels which are not observable. And
I
yet
agree,
they
but
are
we're talking
real.
about your brain and not a
But
particle.
can your brain behave in that way if the brain were considered not something that you can poke and prod? What if love, in fact, does not light up the same part of your brain?
All right, when we come back, more StarTalk Sports Edition, Cosmic Queries with our Geek-in Chief Charles Liu. We'll be right back. We're back. StarTalk Sports Edition, Cosmic Queries Grab Bag with our Geek-in Chief Charles Liu. Charles, how do we find you on the internet?
Oh, well, at Chuck Liu, ChuckLiu on Twitter, and at the Luniverse, TheLiuNiverse, on a wide variety of platforms.
The Luniverse.
Yeah.
I love that.
Podcast is going wherever you get your podcasts. We have lots of
Okay.
conversation and fun with that. Yeah.
All right, cool. And Chuck Nice, you're still Chuck Nice comic?
Everywhere, sir. Thank you.
Everywhere. Cool. Gary, are you still 3 Left Feet
Yes, I am on Twitter.
on Twitter? All right. We're
My
good
3
here.
left feet. All words.
My 3 Left Feet. Got it.
Yeah,
Sorry.
all words.
Sorry. So we got more questions here. Bring it on.
We have. Right. Matt Berg says hello from Sheboygan Falls. I believe that's Wisconsin. Loves the show.
Sheboygan.
You're welcome. I have used many of your discussions in my classroom to have my middle school students think a bit deeper about things.
Teacher in the house.
All right.
Excellent.
Is there a
Excellent.
simple? So here we go. Pay attention. Is there sit comfortably? Sit up straight. Is there a simple way?
I never
to
did that in school. What are you talking about?
Let's start now. Is there a simple way to explain to students what our universe is expanding into? In other words, if the Big Bang Theory created everything in our universe, does that mean that there has to be something outside of our universe, or how can there be a nothing that is being expanded into? At this moment, this gentleman, Matt Berg, his mind starts to hurt.
Oh, that's
Well,
not so bad. There's nothing
That's
wrong
a
with
great
the head hurt.
question. And
Yeah.
in fact, I'll just have you know that a friend of mine who is a doctor, graduated from Ivy League school and Stanford and stuff, asked me that very same question not that long ago. So
Right.
you are in good company, Mr. Berg. Here's my way of explaining it. You are at the center of the universe right now. When we make measurements and try to figure out where the center of the universe was that it was expanding out of, it always goes to you. Whoever is observing observes that they are the center of the universe. So in other words, we are part of the Big Bang. When the universe was microscopically tiny, that is what has become us today. There's no central point because we are at the center. The center just happens to have gotten really, really big. And that's one way of thinking about where the center of the universe is. You are the center of the universe. I'm sure your mom told you that at one time or another, or you thought that you were that at one time or another.
I love
But
when one tells
actually,
you that.
That's right. In fact,
All right, so what are we
physically,
expanding into? Because that's what how
Right.
it started.
Hmm.
the expansion into you can think of as a different dimension. You can think of it as, say, space being three-dimensional, length, width, and height, expanding into a fourth dimension, which
Fourth
is
space
not,
dimension.
yes,
Fourth
a
space
fourth dimension of space, which is not length, width, or height. Or you can actually think of it as a four-dimensional space-time where the expansion direction is in time, Neil, where t equals 0, at time 0 was the Big Bang, the universe was very small. And now time has gone on, t is about 13.8 billion years, and now the universe has expanded in that fourth dimension of time. You can find lots of different ways of thinking about it that are mathematically equivalent. So maybe if you're not like exactly getting the way that I'm describing it, maybe the way that you foresee it or think about it or envision it is just as mathematically valid as the way that I'm talking about it right now.
Wow, that was
Okay.
elegant, Charles. I got to give it to you. That was.
I can't take credit for
was
that.
Really cool, man.
Well, thank you, Chuck. But remember, I didn't come up with this, right? our scientific forebears, have been working on this for a long time. And when they first came up with these ideas, they were hard pressed to explain them and understand them because they're so different from what we thought about when we were in those times. So I'm just
I like to add to it that you can have a multiverse where everybody's expanding, but if you're embedded in a higher dimension, then you will not necessarily collide, even if you can go to infinity. So if you take a sheet of paper and send it to infinity in every direction, so it's an infinitely large sheet of paper. Now I can take another sheet of paper, lift it off of that into a higher dimension, a third dimension, right? And now it's just, quote, parallel to the other one. That can go to infinity and never intersect the other sheet.
And I could do that into infinity.
To infinity.
Yes. And beyond.
To infinity. And beyond, yeah. So if you embed our 3 dimensions into a higher dimension, you can expand higher dimensions and then they'll never collide if they're all in a dimension yet higher than themselves. So
quite
there
so.
you have it. Yeah,
that's amazing.
Right.
So what else we got? Is it Gary or Chuck? Who's got the next question?
Gary.
Okay, you want another one, just like the other one.
Bring it on.
All right, Kartik. Kartik is from Germany. If the Earth's magnetic field is caused by the iron inner core rotating within the magma outer core, how does gas giant planets like Jupiter also have a magnetic field? Do we know anything about the composition of the interior of the gas giants?
We do. And the answer, we think at this moment, is that far enough down in a gas giant like Jupiter, the hydrogen, which we think of as a gas, turns into a metal.
Oh.
It becomes what we call metallic hydrogen. And so you have a core of metal, of conducting stuff that can swirl, just like the core of metal in the Earth. And that's how you can get a magnetic field. That's what we think.
To be clear, we didn't pull this out of our ass. If you remember your
what do you mean
periodic table of elements, if you remember your periodic table of elements, hydrogen is, if it's a full fleshed out table, hydrogen appears twice, once in the upper left and once in the upper right. Once in the upper left is hanging out with the metals, and in the upper right is hanging out with the gases. And if I'm remembering that correctly, Charles, is that right?
It can be written that way, yes.
Written that way. And I said, well, why is it twice? And somebody said, well, sometimes it's metallic. And I said, it's a freaking gas. What the hell are you talking about? Later, I would learn under pressure behaves just like a metal does, just like iron. And so, yeah, so it doesn't have an iron core, but it's got a metallic hydrogen core under all that pressure for sure. And there it is, running the dynamo on Jupiter, a rather ferocious one at that.
Yes.
Oh, yeah.
Sweet. Look at that. That was good.
We got one more in there. Quick one.
Pim Bilek.
Ooh.
I was wondering what you think is the biggest obstacle for developing working warp drive, and would you see this becoming a reality? And if yes, when? Curious about Charles' theoretical view on this.
Ooh. An impatient Patreon member. All right.
So, Pim, here's the answer. Charles has already built a warp engine in his basement. And he can't tell you when it's going to be released because, that's classified information.
The 1.3 gigawatts are still the same. The thing that is most blocking our ability to create a warp drive quickly is physics. The actual ability to travel faster than light at this point through the universe that we have right now, we don't have it. We don't have that ability. So you have to find a way to travel through space, but not in the way that everything else travels through space. So can we actually do what the Star Trek folks are thinking, or Miguel Alcubierre said, where you create a subspace field and you put yourself inside a warp bubble, which can travel through space faster than time because the warp bubble can, but you can't, right? Or is it some other way where you actually have to exit our 3 dimensions and go into a 4th spatial dimension and then come back in? These are the questions. The basic fundamental physics are still beyond us. We can imagine, we can have fun with it.
Give me a
television.
date when we're going to have it.
Next Wednesday.
Next Wednesday at 3 p.m.
According to reliable sources, the date is April 5th, 2063. That is
Precisely.
according to Star Trek First Contact, the movie where Picard
Well, that's where
travels
the-
through
that's where
time
the-
and goes to
he
the
goes-
Borg,
He goes
goes
back
and sees Zephram Cochrane in Montana.
the
right.
one who invented the drive.
That's
Correct.
right. And, the,
day
and
that-
the Vulcans came
And the Vulcans just happened
and
to
they
notice
picked
it,
up his warp signature.
and that
and
changes all of
That
human
changes
history.
up-
Right.
Oh.
That event happened on April 5th, 2063.
Okay, well, there it is then. We got it.
Wow.
That's
That
the
was
date.
I got to tell you, that was
Let's get-
amazing.
Let's get reality imitating art
Hmm.
and make that happen. All right, I'm looking. That's on my. I'm gonna put that in my calendar right now. Right when we're
Good.
done here.
We will party.
All right. All right, Charles. Always good to have you, man.
Thanks so much. What a
All
pleasure.
right, love to the family, and
You
Chuck
too.
Nice. Always good to have you there, Gary. We're all in here.
A pleasure.
Thank
All
you.
right, this
Pleasure.
is StarTalk Sports Edition, Cosmic Queries Grab Bag. That's like the randomest fun anyone can ever have.
Yeah.
All right, Neil deGrasse Tyson here. Thanks for listening, and as always, keep looking up.